So, in the next problem, find the step response of the system with a transfer function 4 divided by s into s plus b plus 4 if b is equal to 4 and b is equal to 5. Also find the effect of b on damping ratio. So, here you can see the transfer function of the system is given. The overall transfer function, they have not specified whether it is closed loop or open loop, but from the analysis we can say that it is a second order system and this is the overall transfer function of the system. So, that is given 4 divided by s into s plus b plus 4. So, two values of coefficient b is given. First one is the value of b is 4 and second one is value of b is 5. So, we have to find the step response of the system. Also the effect of damping ratio. Find the expression for step response of the system that we have to find. Also we have to find the effect of damping ratio on the value of b. So, first I am considering the case when b is equal to 4, that is the coefficient b is equal to 4. Now, by expanding the denominator, I can write the equation of transfer function as 4 divided by s square plus bs plus 4. Instead of b, I can substitute b is equal to 4. So, now our transfer function is 4 divided by s square plus 4s plus 4. Now, as in the previous problem, by comparing it with the standard second order equation omega n square by s square plus 2 zeta omega n s plus omega n square, we can tell that omega n square is 4 and omega n is 2 rad per second. Now, we have 2 zeta omega n equal to what? We have 2 zeta omega n equal to 4 here, that is the coefficient of s. So, here 2 zeta omega n that is equal to 4, by substituting the value of omega n, that we will get damping ratio or zeta is equal to 1. So, we just substituted, we just compared the coefficients of s in the case of the original transfer function and generalized second order transfer function equation. So, when we compare those, we will get 2 zeta omega n is 4 here and we will get the value of zeta equal to 1, that is the damping ratio is equal to 1. So, when the damping ratio is 1, what is the system? The system is critically damped system. Whenever damping ratio value is 1, the system is critically damped system. Now, we can write the general equation for the general expression of a critically damped system. General expression for a critically damped system. So, here this equation C of t is equal to 1 minus omega n t e raised to minus zeta omega n t minus e raised to minus zeta omega n t. This is the expression for output response when the input is unit step and the system is critically damped system. This expression we have derived this expression in the previous lectures. So, you have to remember this equation. When you want to write the expression, you have to remember this equation. So, we can write the general expression for a critically damped second order system for unit step response. For unit step response, that is 1 minus omega n t e raised to minus zeta omega n t minus e raised to minus zeta omega n t. So, substitute the value of zeta and omega n here. So, we know the value of zeta is 1, we have found the value of zeta and omega n is equal to 2. So, substitute those values here and our expression for second order critically damped system is output response, or expression for output response for a second order critically damped system given in the question is 1 minus 2t e raised to minus 2t minus e raised to minus 2t. So, you can do the problem in this way, or else you can substitute R of s is equal to 1 by s here, that is the equation is C of s by R of s is equal to transfer function, overall transfer function is C of s by R of s is equal to 4 by s square plus 4s plus 4. So, if you want to take the Laplace inverse, you can substitute R of s is equal to 1 by s here, and you can write the output response C of s is equal to 4 divided by s into s square plus 4s plus 4. Now, by taking Laplace inverse also, you will get the same answer. You can approach the problem in both the ways. If you remember this equation, it is always easier to approach this problem in this way, if you remember this equation. Otherwise, you can directly find the L inverse of Laplace inverse of C of s. Then also you will get the C of t as the same equation. Now, the second case is if the value of b is equal to 5, if the value of b is equal to 5. So, if the value of b is equal to 5, our transfer function will be changed into 4 divided by s square plus 5s plus 4. Instead of 4, here the coefficient of s is 5. Here also, by comparing it with the standard second order system, standard second order equation, we can say that omega n is equal to 2 rad per second and 2 zeta omega n is equal to 5. Why it is 5? Because the coefficient of s is 5 here. So, by substituting omega n is equal to 2 here in this equation, we will get the system zeta value as 1.25. Now, how did you get the omega n is equal to 2? Because the value of omega n square is 2 here, also in the numerator and the denominator. The value of omega n square is 4 here, then omega n value will be 2. So, if the zeta value is greater than 1, we can say that the system is over damped system. Here you can see that the zeta value is 1.25 and we can conclude that the system is over damped system. So, in these type of systems, when the system is over damped, it is always easier to approach the problem in this way. That is, I am explaining the method here. So, if the system is over damped system, first you write the transfer function, that is C of s by R of s is equal to 4 divided by s square plus 5s plus 4. Now, what is our R of s? The system is excited with a unit step input. The system is excited with a unit step input. Okay, you can see that in the question. In the question they have asked us find the step response of the system. So, if they have asked us to find the step response and they have not specified any value of gain or other parameters, we can always take unit step response. So, here when the input is unit step, R of s will be equal to 1 by s, and substitute R of s is equal to 1 by s here. We can write the equation of C of s is equal to 4 divided by s into s square plus 5s plus 4. Now, I just factorize this equation as 4 divided by s into s plus 4 into s plus 1. Now, by partial fraction expansion, I will be able to find the coefficients of a, b and c, the values of a, b and c. So, find the value of a, b and c by partial fraction expansion or any other method suitable to you. So, if we will get the values of a, b and c like this, a is equal to 1, b is equal to 1 by 3 and c is equal to minus 4 by 3. Now, if we substitute the values of a, b and c in the above equation, I can write c of s is equal to 1 by s plus 1 by 3 s plus 4 minus 4 by 3 s plus 1. Now, take the Laplace inverse of c of s. Then, if we take the Laplace inverse, c of t is equal to, what is the L inverse of 1 by s? L inverse of 1 by s is 1 plus, what is the L inverse of 1 divided by s? A divided by, sorry, what is the Laplace inverse of 1 divided by s plus a? 1 into e raised to minus at. Similarly, the Laplace inverse here is 1 by 3 into e raised to minus 4t minus 4 by 3 e raised to minus 1t. This is the expression for output of the given second order system. Also, you can plot the responses, because the first one is critically damped. When b is equal to 4, the system is critically damped, and when b is equal to 1.25, the system is over damped. We can also just roughly plot the response, output response we can roughly plot. So, this is one approach. So, here why I am saying is that whenever the system is over damped, it is always easier for you to directly take the Laplace inverse. Okay, you can directly you can take the or we can find the output response c of t by taking L inverse of c of s. That is the easier method when the system is over damped. Now, we will discuss another method. So, in the other method, we have to write the equation of c of t, that is output in time domain for over damped system. This equation we have derived, we have explained in the last class. So, in order to write the equation, you have to remember this equation. Okay, you will not get any time to derive this equation in the exam hall. So, you have to remember this equation. This equation is little bit long. So, c of t is equal to 1 minus omega n divided by 2 into square root of theta square minus 1 inside the bracket e raised to minus s1 t by s1 minus e raised to minus s2 t by s2. Also, you have to remember that s1 and s2 are not the roots. They are not the roots. They are defined by these equations. These all we will get these equations from the derivation of output response of over damped system. So, S1 is equal to plus theta omega n minus omega n into square root of theta square minus 1. So, when we substitute the values, we will get the value as 1, and S2 is equal to plus theta omega n plus omega n into square root of theta square minus 1, that is equal to 4. Now, if we get the two values, we already know the values of omega n and theta, we will get the expression like this. So, this is the output expression for output for the given over damped system. This is actually same as in the previous case. Both the equations are same whether we take Laplace inverse of the C of s output, or whether we apply the equation directly, apply the formula directly, then in both cases we will get the same answer. You can compare the answers, both the answers are same in this case and in this case the answers are same. 1 by 3 e raised to minus 4t is 0.03 e raised to minus 4t minus 1.33 e raised to minus 1t. So, both the answers are same, but when the system is overdamped system, it is always easier for you to find the expression for C of s, and after that take the Laplace inverse of C of s, because you can see that the direct application of this equation for the direct in order to find the expression for C of t in the given system, you have to remember this equation. So, this is a little bit long equation and it is somewhat difficult to remember this. So, it is always easier to do the problem by the first method, by finding the C of s value, output response in S domain, after that taking the Laplace inverse. So, in the question, the given question is for B is equal to 4 and B is equal to 5, we have determined the type of system as critically damped and over damped respectively with the values of zeta as 1 and 1.25. Also, we have got the output response, expression for output response of the two systems. Thank you.